In this video, I'm going to be going through the preliminary HSC, or the Year 11 exam taken at the end of Term 3 exam for engineering studies, and I'm going to be going through this fairly quickly. I have typed up some calculations, but I'm not going to be going over them in too much depth. First of all, concrete is made of cement and aggregates. I say this is the most important thing that you need to know about the subject to not embarrass me, so I often lead with that one to give you a nice easy start. Gravity, you should be familiar with, is 9.8 meters per second. So work and energy are both measured in joules. Weight and force are both measured in newtons. Pressure and strength are both measured in pascals, which leads speed is measured in meters per second, and displacement is measured just in meters. Okay, identify the products most likely to be extruded of these options: window frames. Mild steel is an example of, so just engine blocks are cast, rails are rolled, spanners are forged. Mild steel is an example of which of the following? It is a interstitial alloy, because there is a small amount of carbon added to the iron. Substitutional alloy would be bronze and brass. Interstitial alloy, the double would be something like stainless steel is both. It has interstitial carbon and substitutional chromium or nickel. Okay, so this process of heating 900 degrees, quenching, then reheating, that is tempering. Yeah. Okay. What property does cold rolling improve? It improves strength. The highest coefficient of friction is rubber and concrete. I actually even got the notes for this to say, so Copeland talks about this on page 95, and yeah, rubber and concrete has a coefficient of 0.8. The reason I included the ice is because I wasn't sure that that was something that you'd be familiar with, and I wanted to try and make it not to be too difficult. Okay, so for this one here, the velocity ratio, this is our first of our calculations. So I'll bring up our calculations notepad, and what I have here is that velocity ratio is equal to the distance traveled by the effort divided by the distance traveled by the load. I'll just check that you can see all of that. I may not have had... Windows sometimes thinks it knows better than me in terms of how big I want. I don't want it to be that big. Okay, they'll have to do. Okay. So this is all the working out I'm going to show in this exam. Okay, so the distance, now they haven't said explicitly which one is the load and which one is the effort. We're going to see in a second why that doesn't matter. So if we just take the load as being this force here, if we take the effort as being that force there, then what we have is the perpendicular distance is what we've got to remember. So the perpendicular distance is, this is going to be, if this is 1300, well, the perpendicular distance is going to be some number smaller than that, because 1300 is going to be the hypotenuse. I'm not going to draw an isosceles triangle because it's 45 degrees, it would be an isosceles triangle. The perpendicular distance of that triangle is going to be 1300 sine 45. I didn't write 1300 sine 45 because I already know that sine 45 is 0.707. I only know two trig numbers, and that's one of them. Okay, the other one being the disco number. So when I multiply 1300 by, or I've used meters, that's fine. 1300 by 707 divide by 0.6, I get 1.3, which is one of my answers. If I'd done it the other way, I would have got an answer of 0.65. But that wasn't one of my choices, so that way I don't have two correct answers. So it didn't matter which way you did it. There's only one way that you could get the right answer. Okay, so the next we're going to find the force required to balance. So we talk about like seesaws. If we have two small kids, and what is the force of the mama bear needed to balance out those two cubs? Well, so we've got some of the moments about A equals 0. I didn't write that because it's hard to write some of the moments about A clockwise equals 0. So I've just said 0 equals, and I've got minus 40 because it's going anti-clockwise, times not 0.325. I've used meters here. Normally I would probably use millimeters, but I used meters here. Not 0.325 but 0.725 because it's actually 0.325 plus 0.4, right? And that's why I use brackets as my notation when I'm doing moments. Then I'm multiplying 40 times 0.4, and that's also going anti-clockwise, which is why it's negative, plus f, which is 0.3 away. When I can add these numbers together using, like, cool math tricks, and divide by 0.3. Say 0.7 plus 0.4 is 1.125. Multiply that by 40, divide by 0.3 gives me 150, and that's one of my answers, so we can move on. Okay, so the next one is, yeah, that's fine. Which defines ductility, ability to be drawn into a wire. The SI unit that measures the flow of electric charge is the ampere, so current, and current is measured in amps. Okay, so common electrical safety devices used in residences. We have, it's not really capacitors, they're not safety devices. Neither are diodes, capacitors again, and here we've got circuit breakers and residual current devices, also known as safety switches. Perlite is a lamellar or layered mixture of I was worried for a second. I couldn't see the answer. Cementite and ferrite. Normally we'd write ferrite and cementite because ferrite is typically on the left hand side of the equation. Okay, what is the stress due to a force of 10 kilonewtons applied to a rod with an area of 1.3 millimeters squared? Sorry, 113 millimeters squared. Okay, so if we go back here, we've said stress equals force over area. Now, when we're using Greece units, we go together like megapascals and millimeters squared. So our force is going to be in newtons, right? SI units, which is 10,000. 10 kilonewtons is 10,000 divided by millimeters, which gives us a number of 88 megapascals. A box has a mass of 80 kilograms. What is the coefficient of friction? So again, we've got F equals mu n. That's actually a mu, but again, I'm just typing these in pretty quickly. Mu equals F divided by M. F is 200. F is 200. N is 800. That 200 divided by 800 is 1/4. So that's A. Then we've got, okay, which best describes engineering management? Oh, this is probably a past HSC question, and the fact that I'm not confident at the moment, let's have a look. Okay, see, I think I used this a long time ago. This is like from maybe my 2014 paper, I think. Tradespeople and specialists throughout project stages. Oh, no, okay, no, sorry. I'm reading through this properly. The efficient use of resources to achieve project outcomes. There we go. That's the answer. B. Lock it in, Eddie. Okay, do people still know who Eddie is? Hopefully they know who Eddie is. Okay, I haven't looked at this one already. Let's have a look. Okay, so output Z is 0. If output Z is 0 in all cases, and this is an OR gate, this is an AND gate, so it means that this has to be on in order for it to work. So X and Y have to be on. So D. Yeah, so X and Y are on. The AND gate says they're both on. The 1 goes through to the OR gate. The OR gate says 1 and 0 is 1. Yep. Okay, which of the following is not correct? Cast iron. Okay, so I try to avoid using not correct unless I can't really phrase it any other way. Maybe not when I wrote this paper, but I wrote this a couple of years ago. So it's true, cast iron does have good machinability. Cast iron, it's not more ductile than steel. Okay, cast iron has good vibration dampening. Yeah, so B is not correct. B is not correct. Okay, so now we've got a resistance question. So what we've got here is 1 over the total resistance of in parallel is equal to 1 over R plus 1 over R2. So so this is R1 and that's R2. So I've said 1 over 2 plus 1 over 5 is the same as saying if we give them common denominator, 5 over 10 plus 2 over 10 was 7 over 10. if we invert that, so we have 1 over r, well, if we invert that, we now have 10 over 7. 10 over 7 is 1.4. And so this part here is 1.4 plus 3 is a total of 4.4. And that's B. Okay, we're done our multiple choice. So we're on to now outline one ethical consideration. Right? Okay, biomedical engineering, the one that everyone likes to talk about is the deaf community, but you could also talk about animal testing. You could also talk about DNA and privacy. I think in my 2004 I listed like several different things, but price gouging is another thing you could talk about. Yeah, that's out. So it says outline 1. So if there's 3 points. Outline is one of the HSC keywords I don't really like. I can't remember, and don't have a nice ready to go window to look it up. But outline to me just means write 3 sentences. I think it's like key points or something like that. What a teacher. Am I going to get it? No, I'm not. Sketch and what? Sketch in general terms. There we go. Thank you for that. Okay, so sketch in general terms. Really, I mean, I have spoken to other HSC markers and said, what does that even mean? I don't know. So for me, it's just write 3 points. It's an A, so the marker is probably going to be fairly generous on A's. So outline 1 in consideration. Let's go with animal testing. So we could say that animal testing is an essential requirement for testing of new medical products and both techniques and let's say medical techniques and new medications, new medical treatments. However, it's important that this is done humanely, and in Australia, this must be done under the oversight of an ethics committee. That's 3 marks. I've written 3 different sentences, and so I've established what the benefit is, what the concern is, and how we deal with it. Okay, explain why designing engineering products to minimize environmental impacts is preferable to recycling. So this is the whole reduce, reuse, recycle question. The answer here is that not all materials can be efficiently recycled. Some materials effectively can't be recycled with our current technology, or it's not practical to recycle them. And even when we do recycle, there is still always going to be some use of energy consumption, and energy consumption usually is going to have some greenhouse gas emissions. Even solar has some greenhouse gas emission. I guess if it's nuclear, it has no greenhouse gas emissions or very little greenhouse gas emissions, but it has its own risks. And some materials can't be efficiently recycled, and doing so still produces some amount of greenhouse gas emission or other waste. Removing the most effective solution to reduce our use of non-renewable resources is to reduce materials in the design stage. Okay. Describe and evaluate the impacts of lawnmowers. I didn't even say what kind of impact. So describe is features and properties and characteristics. It's one of those two. So explain is a how and why, by the way, if we're cubing. Describe, I'm going to say, is it's either features and characteristics or characteristics and properties. It's some combination of the 2 of those 3. Okay, describe and evaluate. Oh, okay, there we go. Got the how and why. I almost missed that evaluate. Okay, so evaluate means make a judgment. So state for and against and make a judgment. So it says impacts. So if we were cubing, we would also put a box around that S to tell us we have to have 2 impacts. So we could say lawnmowers have had a social impact in that they improve the appearance of our lawns and reduce, they also have a health impact in that they can reduce rodents living in tall grass and things like snakes. However, they have a environmental impact because their production uses non-renewable resources, and they typically operate on fossil fuels, which produce greenhouse gas emissions. However, as a society, we generally consider that lawnmowers are a net positive. There we go. So what I've done is I've talked about argue the case for and against. Really, these days I probably would just cut out that and I just say evaluate the impacts. Describe. I guess I was trying to say, so evaluate should always include the lower level, which is describe. But I think it is a bit of a trap to have describe and evaluate. These days I would just write evaluate. Okay. Sketch and label the microstructure of 0.3% carbon steel in the circle below. Oh, okay. Now I will pause. Okay, so I'm back, and just taking straight away from Copeland, he has figure 3.11, which shows a hypoeutectoid, so steel with less than the eutectoid, or less than 0.83% carbon steel. And they were asked to draw in 0.3. 0.3 is pretty common. With 0.3, about half of it should be a perlite. Generally, just to show perlite, we just draw a bunch of grains with lines. Is how we draw perlite. Now, the next thing it says is to draw now, it's always important we have to label, right? There's 2 marks. You will lose a mark if you don't label. It is very common that people don't label, so that's why I'm really stressing it. The properties and grain structure view shows a lot of those eutectoids as well. I mean, this is... Now, when you're drawing this, there's lots of different ways you could draw it. This is actually, I'd say, about 0.3%. And then this one here is work hardened. So we can see this drawing here. We have elongated grains. And funnily enough, actually, that video that we talked about earlier, just a second ago, it shows work hardening. It's going to roll the steel. There we go. It shows work hardened, the crystals of work hardened steel here as well. Okay. Describe the resulting changes to mechanical properties and the grain structure. So what we'd say is when it's work hardened, or work hardening causes elongation of the grains and improved strength and reduced toughness. And then, yeah, label the diagram that there you just need to draw elongated grains. That would be how you'd label it. So elongated grains. Identified 2 forms. You'd still need to show perlite and ferrite because they've said that it's the same steel. Identify 2 forms of welding and identify their applications. So if we go to this post on Facebook, but this is now in the notes that I give at the start of year 11, we have 4 main types of welding. We have the 3 electric types, or arc welding, stick, MIG, and TIG. The proper name for stick is shielded metal arc welding. So if we were talking about that, it's good for use on site, especially things like pipelines. MIG is typically used in factories. TIG is used for aluminium and stainless steel. Oxy is used where electricity is not available, also for thinner metals. Okay, explain how electricity can be used to produce the movement of a DC motor. Okay, so if we're cubing this, we've got explain, which is how and why. Explain. Oh, it's funny. Sometimes when you look at it carefully, you realize the sentence doesn't make sense. Explain of how. Okay, explain how is what we're presumably looking for. Explain how electricity can be used to produce the movement of a DC motor. You know what? I'm going to make that change. Explain how electricity. So movement plus magnets. Okay, so explain is how and why. So it's our C. Our underlining, I guess, electricity. DC and box, yeah, there's nothing really here that needs to be boxed. And then our E is movement plus magnets equals electricity. So what we can say, and I do have, I give specific examples of how you can answer this question when we do our electronics quiz, but I would say off the top of my head that the current flowing through the armature creates a magnetic current which reacts to the static magnetic field of the stator, and this generates, causes attraction and repulsion, which causes the armature to turn. It's maybe not my best terminology ever, but it's good enough, and I would be happy to write that down without any concerns. Okay. The picture below shows three components of hip prosthesis, the stem, ball, and cup. So the acetabular cup, actually that's not even a cup, to be honest. I have a better understanding of these things than I maybe did in the past. That I don't even think that's the cup. I think that's even the liner, because the cup is usually made out of titanium. Anyway, so no one has ever pointed that out to me before. Okay, so what does the lines look like? It's forged. We've talked about this fairly often. So the machined stem will have lines going in the same direction. The forged stem, the grain will flow around the shape of the stem. This has a benefit of, compared to a machine stem, a forged stem will be stronger and less likely to fail. So it has fewer points of weakness. I'm tempted to get a picture of forging, except that I've just done that so many times that should be familiar, and I don't think if that's a concern, let me know, and I will provide you with a picture of forging. Okay. For the same hip prosthesis, the cup has been made of a thermosoftening polymer. Oh, that's the liner has been made of thermosoftening polymer. Identify suitable material and manufacturing process for the liner. Okay. Yeah, okay. I'm going to change that for when I put this up online. So I've shown here, I guess, the cup, but this as the cup. And we're saying that cup has been made out of... so the material, the polymer you use is polyethylene. You could write ultra high molecular weight polyethylene, and the identify suitable material and the suitable manufacturing process is injection molding. Okay. Okay. Copper wire is... I have been using that question for a long time and didn't appreciate that. Yeah, I talk about the cup. Anyway, okay, so copper wire, this long, that area, this Young's modulus, calculate the extension if the force is that. Okay, so here we've got E equals flea. We can rewrite that as E equals flea. F equals 300, L equals 200. The capital E, the Young's modulus, we have to convert gigapascals into megapascals because we go together like megapascals and millimeters squared. And of course, we're keeping our units in millimeters because otherwise it wouldn't work. And that's going to give us our answer. Yeah, we're using megapascals and millimeters. Okay, when we divide that out, we should get 1.09. Now, it's always a good idea to think about these things of like, what is a reasonable answer? And if you're getting an answer that is, more than a couple of millimeters, something should be going wrong. I won't harbour that point too much, but just thinking about what is reasonable values. For steel, the Young's modulus is usually 210. That's why I try to use these days materials that aren't steel, just because otherwise if someone sees something that they're not used to, then they can say, well, it didn't look right because I only got 96 or whatever gigapascals. Okay. For another load condition, they've said the extension is 0.6. So strain equals extension over original length, which is 0.6 millimeters divided by 200 millimeters. So a trick that you could have done, if I wanted to make this question tougher, is I might say 0.2 meters. That would be a tougher way of writing this question. Then you'd have to convert units. But I think I made these out of 2, so I didn't want to make it too difficult for people. Okay, we have a hydraulic system. So the big thing to check out is the cylinder has an area of this. It has a diameter of those. I think when I did this, I actually had to tell the class in the hall that it's diameter. Yeah. Hard to write papers. Okay, so calculate the force on Y. Okay, so what is our diameter ratio is 1 to 4. So if we square that, our area ratio is going to be 1 to 16. So that means if we're putting in 100 newtons, we're going to get 1600 out, or 1.6 kilonewtons. And so our velocity ratio is equal to our diameter ratio, that's squared. So I did write the right things there. Okay. Or it's equal to the areas if you have the area ratio, but if you don't have the area ratio, just big diameter squared divided by little diameter squared. We've said that mechanical advantage equals velocity ratio because we're assuming it's 100% efficient. And then we get 1600. I like this method. I only saw this method of writing it recently, and I do like that method. So, okay, here we have a pulley system that we're using 100 newtons to lift 270. So that's already a mechanical advantage of 2.7. And if we look at the pulley, we can see there are 3 ropes attached to the movable pulley. So 2.7 divided by 3 gives us 90% efficiency. Okay, I think this is straight out of Copeland's textbook. Calculate the force that lifts the wheelbarrow. So I definitely have a video that explains this in greater detail. I don't know what exercise it is, unfortunately, but I definitely have explained this. Find it in the textbook, and then from there you can then find a video where I go into more detail. But what are we going to say? Okay, first of all, we've got so we get some of the moments about R, or about A equal 0, and we're setting clockwise as positive. We've said that our mass of 24, which is going to give us 240 newtons, because we're assuming this is on Earth, multiplied by 400 millimeters. I'm using millimeters. That's okay. We said we're allowed to use millimeters when we're doing megapascals or if we're doing moments. And then we've got our F. F is going anti-clockwise, but the trick is that it's that perpendicular distance again. It's that perpendicular distance that we're looking for. And to find that perpendicular distance, we're using some trigonometry. We know that this angle here is 15 degrees. So if this angle is 15 degrees, we're going to find the adjacent angle. So we're going to write 1215 cos 15, which I'm told is 1174. Hopefully it is. And then if we divide those two numbers, yeah, that looks like it's about, so it's 96 divided by 1 and a bit. Looks like 82 is a bit right, yeah. 96 divided by 1 point and a bit. What was it? 1.17. Yeah. Okay. Then we have to find R. So it's just the sum of the forces vertically. So how much up have we got? How much down have we got? We've got 240 down, and then F is giving us 82 up. How much more up do we need? It's going to be more than 100. How much more? 158 is the additional we need to balance that out. Engineers use both freehand drawings and CAD drawings. Compare these two models, these two methods. Okay, so they're not looking. Comparing means discuss how things are similar and different. Okay, so if we're comparing, what we're saying is that both of them are used to communicate information to stakeholders such as manufacturers and the client. However, freehand drawings are used to communicate information quickly, particularly in the very early stages of design, while CAD software has a number of benefits. The 3 main benefits we talk about are sharing and storage. I'm including them as the same thing. The editability, that it can be readily changed and modified and adapted. And then the third thing is integration with other software. So everything from 3D printers to surveying software or surveying hardware as well. So they're the 3 main considerations we're looking at. If you just wrote any one of those, that'd be good enough. So another thing you might say is that freehand drawings so both communicate information to clients and manufacturers. However, freehand drawings are much faster and are used in the early stage of design, while CAD software can be used when because it can be integrated into computer-aided manufacture, or because council drawings require a high precision output, and CAD software can be easily edited and provide a variety of views. Okay, engineers use both orthogonal drawings and pictorial drawings. Compare these two methods. Okay, so what is similar about them? Both drawings are used to, again, same thing. Both drawings are used to convey information, particularly to manufacturers. However, orthogonal drawings are used to provide a lot of detail and usually dimensionings, and usually dimensioned, whereas pictorial drawings are used to give an overall concept of what we're doing, and they're more intuitive. Yep. Okay. Now these two I'm going to record separately, and I will splice that video in, or I'll put it in as a part 2, because I'm going to do those on the board. Thanks.